Type of person who sometimes wakes up at 3 a.m. and lies in bed trying to wrap your tiny mind around the achingly vast universe and where it's all headed, well, we have something for you. Ever since the Big Bang, the universe has been drifting and expanding. The birth and death of stars leave an aftermath of galaxies, planets, and even living organisms. This includes the sun, planets, and our solar system. At the center, the sun swept in smaller elements like hydrogen and helium. Farther away, heavier elements formed planets. Based on the core accretion model, gravity was the driver, coalescing Earth from a cloud of dust. Though Earth was neatly orbiting the sun as a rocky mass 4.5 billion years ago, no organism could survive there. Radiation from the recent supernova kept the planet extremely hot, its surface molten, and oxygen was non-existent. Plus, incredibly massive meteorites and asteroids frequently slammed onto the surface. The Earth got so hot it began melting. Heavier material sank to the bottom. Lighter stuff rose to the top. Some elements evaporated. This transformation created the Earth's layered core and mantle, crust, atmosphere, and magnetic field. Without it, Earth would be blasted by harmful rays from the sun. In the late Hadean Eon, the Earth was still in its late bombardment stage. There is no life. Temperatures are extremely hot, with frequent volcanic activity and hellish environments. The atmosphere is nebular, possibly early oceans or bodies of liquid water. The Moon is formed around this time, probably due to a protoplanet's collision into Earth. In addition, there's reason to believe that these collisions could have sparked the chemical building blocks for life, DNA. Eventually, the climate on Earth became more stable. Instead of a molten state, the Earth started to cool down. Water vapor condensed to form oceans, and the Earth cooled down enough to create continents. Vale Barra became Earth's first supercontinent. Photosynthetic organisms appeared between 3.2 and 2.4 billion years ago and began enriching the atmosphere with oxygen. Single-celled organisms consumed the sun's energy. As a waste product, this cyanobacteria eventually filled the oceans and atmosphere with oxygen. Earth now had an oxygenated atmosphere for new life to flourish, but it wasn't cyanobacteria. Oxygen was toxic for them. Much life on Earth probably died out as its levels rose in what is known as the oxygen catastrophe. Imagine a dominant species polluting the planet until extinction. Resistant forms survived and thrived, and some developed the ability to use oxygen to increase their metabolism and obtain more energy from the same food. At this time, methane was more abundant in the atmosphere. One thing that methane did very well was trap heat in the atmosphere. It's one of the most efficient greenhouse gases. So when oxygen combined with methane, it produced carbon dioxide. All of a sudden, the greenhouse effect wasn't as strong. As a result, the whole planet froze. It was snowball Earth for the next 300 million years. As oxygen filled the atmosphere, Earth's ozone layer thickened. Before the presence of an ozone layer, life was restricted to shallow water. Because water shielded harmful radiation, that's where life existed. Eventually, a thicker ozone layer enabled life to diversify on land. 541 million years ago, hard-shelled invertebrates originated in the oceans, and life got more diverse from there. Next came the age of fish, when thousands of fish species arose. Plants and fungi were the first to venture out of the water, requiring them to adapt to new conditions on dry terrain. Some fish stayed in close proximity to land and gradually adapted to life there, simultaneously developing lungs. Amphibians were the first vertebrates to make the move to land. The transition to life on land benefited these creatures because there was no predators to begin with, and food was plentiful. That was the start of the age of amphibians. Then, 250 million years ago, was the Permian extinction, which caused extinction of 95% of all living species. When Earth's climate became hotter and drier, rainforests collapsed, triggering the age of reptiles. Unanimously depicted by Tyrannosaurus rex, locked in eternal conflict with mortal enemy Triceratops. Because reptiles evolved to dry land conditions, they gained a unique ecological advantage. Also notable is that Pangaea existed as one supercontinent in this era. Dinosaurs lived on one supercontinent. Plate tectonics were the mechanism that eventually tore continents apart. Don't forget that dinosaurs existed for 160 million years, so continental drift gradually rifted dinosaurs apart. From between the feet of stomping dinosaurs, ratty animals scurry about, cue an asteroid impact, and the age of mammals begins. Mammals evolved from mammal-like reptiles called therapsids about 200 million years ago, and birds from small theropod dinosaurs about 150 million years ago. This evolution of both mammals and birds accelerated after the extinction of the dinosaurs 65 million years ago, when a 6-mile-wide asteroid struck Earth just off the Yucatan Peninsula. This ejected vast quantities of particulate matter and vapor into the air that occluded sunlight, inhibiting photosynthesis. 75% of all life, including the non-avian dinosaurs, became extinct. Poor dinosaurs, imagine that if the meteor never hit Earth, we would be intelligent dinosaurs. The first true mammals evolved in the shadows of dinosaurs and other large archosaurs. When dinosaurs roamed the Earth, mammals were very small and were probably nocturnal to escape predation. And because dinosaurs went extinct, mammals emerged as the largest land animals at the time. Creatures like Ambulocetus took to the